Okay, so today the short tutorial will go about using the TI toolbox to create these types of visuals. So this is assuming you have some experience, minimal, but some experience with the TI toolbox, and that you have it installed with Docker available. So before we begin, we can look if something is running in the background, and it's not. So we can load the toolbox either with the bash script or with the TI toolbox desktop application. I'll use the bash for now. So we will users, and I will point it to a directory that contains some data. We will launch it, and we're in. We'll call the graphical user interface. Here we go. Okay. So by default, you will not have the 3D visualizer on your tab. It will look like this. So you can go to the extensions and either access it by launching it directly from here, or you can add it to the tab if this is something you'll be doing frequently. So this 3D visualizer is really an integration between TI Toolbox and Blender. It has 4 main modes. And the first one is regarding cortical regions, specifically exporting STL and PYL files to show electric field distribution on specific regions of interest based on atlases that we provide. The second mode is about vector visualization. We won't speak about this one today. Subcortical targets, and the main thing I want to talk about today is the montage visualizer. It's a pretty straightforward tool. It doesn't require much user input. So we allow users to manipulate the electrode geometry. So for illustration, I will just decrease the electrode diameter to 8 millimeters. And the two interesting elements are these, where we allow the exportation of a GLB file. It's a convenient file, it's shareable, it's web friendly, so we might as well do that. It doesn't require much processing time. And this one allows the user to decide if they want to show just the montage electrodes or the entire net, EEG net that is, with the montage electrode highlighted. So to reduce processing time for the tutorial, I will go ahead and show only the montage electrodes. And I will change to Ernie. This is a nice simulation, and in order to be able to do this, one has to have a simulation output. So if you don't have one, please do it. Pre-process some DICOMs or use the default subject we ship with the toolbox, which is Ernie. Create your M2M directory, run a simulation, and then you can go ahead and do that. So I will start an export. Go ahead here and modified. Go to our project directory, and here it's already done. I will clean this for now. And what we got, or what you will get, is this output. 5 files. You'll get the STL files for the scalp and the middle layer of the gray matter. You'll get the .glb file, which is fully baked file that is ready to be shared, showing your head model with one channel and another channel. This is also web friendly, so it's a really nice file. And the key player is that .blend file, where it's named after your subject, your simulation, and if we go ahead and open that, which requires Blender, we have a fully baked, pre-configured scene that contains the head tissue, the electrodes, and some sensible defaults when it comes to the lighting and the cameras. So if we go to the hero camera and we'll go to the view, we can see this. If we change here to the viewport with the material preview, then we can make it really nice. We can change between cameras. So let's say we can go to the left camera, or we can even manually manipulate the scene. For now, we'll go to the left camera. We'll hit F12 to render it. And we have a rendered image. We can save it as demo. You can compress it, you can change the color depth, and you then go ahead and save. And we can open it. Nice. To continue, build on top of it. We can take now, let's say our goal is to show our region of interest. So we can either go to the cortical regions or we can go to the subcortical regions. Let us go to subcortical, and we will remove all small disconnected components. Sometimes the segmentation of the nifty file can be a little jittery, so we'll do that for visualization, polishing, and then by default you'll have this file available, which gives you some room to play. But if you need a more extensive option, then you'll need to have a reconstruction with free surfer, which we allow, but it's not required. So let us decide the region of interest. I will do 1049, which are the left and right thalami, and we can clear the console and run an export. It's a pretty quick operation. You see it's already complete, and it created a designated subdirectory. We'll go ahead and you see a nifty file, a mesh file, and an STL file. You can go ahead and close that. And if we go to Blender, we can import that .stl and drop it just like this to our scene. And because it's the same space, it's the same head model, it lands directly in place. Okay, so what we can do is we can observe it. Looks quite nice. Okay, and just for illustration, we can do some material manipulation. So we want to make sure we have it selected, which is shown with that orangish outline. We'll go to material, we'll add a new material, and we can play with the color. Let's make it greenish, yellowish, if a thalamus was like that, and nice. Let's do a different orientation now. So we'll go to the top, go here, great, F12 to render it. Very nice. Image, save as, demo, and sub call t call. Save, close, and we have a publication figure or a presentation, whatever you need to do. Now, if one does not want to use the graphical user interface, you can use the command line to do the same. So we want to use our Blender. We don't know what it has, so let's use the help flag, and you can see what input it accepts. If you don't want to do that, we have our interactive mode. So if you call a tool with no arguments, you will be directed automatically to the interactive mode, and you can do pretty much the same thing, maybe minus a couple of advanced decisions. But for now, we can do, let's say we want to do the entire net. So we'll go ahead and do that. Take a little bit more time. Nice. Let's see if it indeed finished. So let's don't save, and we can let's do this. That should be the one. Yes, and we have our entire net. We're able to do the same. Okay. Now, if you need a reference, then always go to the website wiki. The CLI tab will assist you with how to approach a CLI operation, but you always have the graphical user interface available to you. And if you have specific questions regarding a tool, then you can go, for example, into the Blender integration, where you'll have some explanations and some examples of what is available to you with the TI-Toolbox. That's it. Thank you. Reach out with any questions. Good luck.